So you probably think about remainders like this. Like you've got some dividend, like for example, 190 goes into 192.
Okay.
Not 190, 180. Goes into 192 one time with remainder 12.
Okay.
Right? That's pretty much how it works. Okay, so I'm going to show you a different way to write exactly this same thing.
Okay.
Okay? I'm going to say 192 equals 180 times 1 plus 12.
What? That's so weird.
Okay, so I'm just taking this 1 right here, and then I'm taking the 12 and putting... I'm writing exactly the same information in a different way.
Okay.
Okay? Because, and I'm going to do another one to illustrate what I'm going to do eventually. Let's say I divide 90 into 192. Right? This goes 2 times with remainder 12.
Okay.
Right? So that means I can write 192 as 90 times 2 plus 12.
Okay.
So what I'm really doing, if I want to find these numbers that work to give me a remainder 12,
Yes.
what I need to do is I need to factor 180.
Okay.
And so here's the idea. Subtract the remainder and then it becomes a divisibility problem.
Subtract the remainder?
Like if I subtract 12 from 192, now what I'm asking for is a remainder of 0, which means evenly divisible.
Okay.
You see what I'm saying? So instead of asking this question about the number 192, let's ask the question about 180.
But why did we choose 180?
Because it's 192 minus 12.
Okay.
All right.
Can you stop the video for a second?
Sure. All right, so we had to pause the video. Now we're recording again. And we looked at subtracting the remainder, and then it becomes a divisibility problem. So I'm just going to write out kind of quickly what we just went over. So in general, when I'm dividing B into A to get Q with the remainder of R, for example, I could be dividing 60 into 180. Whoops, not 180. Of course not 180. 192. And I get 3. And then down here I have 3 times 60 is 180 with a remainder of 12. So I've got the division theorem. This thing turns into A equals B times Q plus R. Here's a very specific example that we've known since 2nd or 3rd grade, right? And so we're going to say 192 equals 60 times 3 plus 12. Okay, this is still a little bit fancy. What we're doing here actually is if I go ahead and subtract 12 from both sides, what I get is 192 minus 12. Of course, that's 180. And what we've done is we've figured out one possible factorization of 180. So in other words, if I subtract the remainder from A,
yeah,
what I'm doing is I'm factoring what's left over.
Okay.
Okay, so, and then we said the best way to list all the factors of 180 is in pairs. Yeah, let's back up a little bit so we have enough room. And then there was one little caveat at the end. What was it? So 9 is 20. And what's the caveat at the end that we have to be careful about and not...
12 or under cannot have a remainder of 12 or more.
Right, exactly. So these,
or not a remainder.
Because it's a remainder problem, it's not exactly a divisibility problem. It's not saying factor all the numbers in 180.
Yeah.
So we got to be a little bit smart and realize that these are no good. And then we want to find the median of this list, and we've done it in order. What happened? Oh, I messed up. There. I'm crossing off 4 numbers here and 4 numbers here. So the median is 36.
Mm-hmm.
Okay. So, I mean, this is like the first time you've ever seen the division theorem in action. Won't be the last. It's kind of hard, actually, to get why it's useful because it's so abstract.
Okay.
But, again, the big lesson is to subtract the remainder. Median is 36.